Hi, today we're going to learn about a useful property called density. Density, like color or hardness, is a physical property that allows us to figure out what stuff is or made of. So, what exactly is density? One way we can look at it is basically how much stuff there is in some amount of space we have. So here we have the stuff, and it's within a defined amount of space, shown by the red box. And from that definition, we can look at it from two perspectives. That stuff could be rather large, like people, for example. We can say the subway car in Japan is denser than, let's say, your classroom. However, for this video, what we're going to talk about, a question to think about during this video. Why does a brick sink? This brick here. Why does a brick sink while an identical looking block of wood floats? We'll take this up at the end of the video. Now, some of you probably aren't satisfied with my definition. Density, while I express it in words, it's almost always represented as a value. So, if we go back to my first definition, density is the amount of stuff compared to the amount of space we have. So it's the stuff over the amount of space. Now, from a scientific perspective, the stuff is what we'd call mass. And that would be something in like kilograms, for example. Mass would be in kilograms. The space is called the volume. And this value would be in something like meters cubed, for example. Thus, the equation for density is mass over volume. Mass over volume. And in this case, the units would be kilograms per meter cubed.
So now that you know what density is, let's try a question. Here we see a box with the given dimensions and mass, and we want to find its density. So let's begin by writing down the equation. Density equals mass over volume. And we have the mass because it's given, so it's 32 kilograms. For the volume, we have to use the volume of a cube, so it's length times width times height. So 2 times 2 times 2. And that's in meters cubed. So if we work this out, it becomes 32 kilograms over 8 meters cubed. So 4 kilograms per meter cubed is the density.
So now that we know about density, why is it useful to us? Well, if we know the density of the object, we can explain a lot of things on how that object interacts with the Earth. So, for example, density gets these bragging rights as a property independent of size. Independent of size. So, for example, if I have a drop of water and a bucket of water, their density is still the same, because since density is just a ratio between mass and volume. Density can also tell us how pure a substance is. Let's say, for example, we have a full glass of water here, and we know that water gets this really awesome density of 1,000 kilograms per meter cubed. And we want to make sure that this is actually pure water. By taking a known volume of this water and weighing it, we can use this formula to figure out its density, and then from that we can tell if something's been mixed in or not. So we have our sample, and if we figure out that the density is greater than 1,000 kilograms per meter cubed, then we know for sure that something must have been mixed in.
Now let's think about density in terms of liquids, solids, and gases. Normally, solids are denser than liquids, and liquids are denser than gases. The particle theory can help us explain this. According to the particle theory, the particles in solids are packed closer together and have strong bonds between them, like this. In liquids, the particles are a little more far apart and have more movement. And in gases, there's lots of space between the particles, and they can move as much as they want. Just like that. As you can see, solids are more dense than liquids because their particles are closer together. And the liquids, likewise, are more dense than the gases. This is the reason why solids are generally denser than liquids and gases. Of course, there are some exceptions, such as ice, which is less dense than water, and liquid mercury can actually be denser than some solids.
This wraps up the video. We hope you've learned something new. Now, before we leave, let's go back to the question we had earlier in the video. Why does a brick sink while a similar sized block of wood doesn't? Well, we have to look at the density of the brick and of the wood. The block of wood here floats because it has a much lower density than the water, whereas the brick, it sinks because it has a much higher density of the water. Now, using your same knowledge, can you think of why a helium balloon rises when you let go of it? And lastly, now time for a real challenge. Can you find the density of the white shell here? You now have to use your knowledge of both shapes and volume.